Right, this is the e-learning that I mentioned. We have two PDF file here, right? So I want to share with you I'm stop sharing. I want to share with you the one file, okay, in the PDF file. Okay, let's reshare. Okay, stop sharing. Okay, right. Okay. Mm. So now, okay, you can see here, all right, we already learned about we have the initial value problem where we have the condition y not equal to 1. Okay, y not equal to 1, and then x between 1 and 2. Okay, we have the initial condition, right? Okay, there is a condition for the initial value problem. All right. So how to solve? Okay, by using yi plus 1 equal to yi, okay, plus hfxy is one of the solution. If you want to go for the higher order, right, so you go to y prime prime and y prime prime prime, higher order derivative. We call as a higher order derivative. All right, based on this equation, okay, you need to know the h. H is a size of interval, is a between 0 and 2. Okay, 0 and 2. So when we find x naught equal to 0, okay, x1 equal to 0.5, x2 is equal to 1, okay, x3 is equal to 1.5, x4 equal to 2. So how to get the maximum grade n? N is a b minus a divided by h. We try to compare with the exact solution, okay, exact solution, because we want to find the accuracy of Euler method. All right. You can also find through the um, Taylor methods. Okay, you can compare with the Taylor methods and then compare through the exact solution. What is the exact solution? Y equal to 2x. Okay, here. Okay, you can see very clear here. Okay, 2 exponent x squared divided by 2 minus 1. All right. So now, um, okay, we need to create a table. Okay, the important is we need to create a table between the exact solution and approximation solution, right? So now, okay, the way how to solve, I give you three steps here. The first is find the domain in the table. Okay, what is n, x0, x1, x2, x3, x4. What is h? H is a 0.5. And then what is the formula for Euler? Okay, yi plus 1 equal to yi plus hfxy. All right. Okay, so we already remind you again and again. All right, so now, okay, so now we stop sharing. Okay, we go to the others. Okay, we go to the others. Stop sharing. Okay, go to the all right. First order. Okay, I want to go to another one. Is what we call here is chronic. All right. Let's we share with you. Okay, make it more bigger. Right. Okay, let's I share with you. Okay, the initial value problem. Okay, initial value problem. Okay, for solving the ordinary differential equation. Okay, you can see here. Okay, the nature that we solve right now is one-dimensional problem, right? Where I plus one involve information from one of the previous point. So that is a nature for the one-step method. For example, Euler method, Ranch kata, and uh, mm, Taylor's method. So this is a process, okay, where I plus 1 to get y3, we need to know the value y2, right? So we need to use yi plus 1 and yi for future approximation to get yi plus 2, for example. So that's we call as a one step, okay? The method, okay, we learned already in chapter 8, numerical 1. What is that? Is a Taylor method, okay, Ranch kata method, and Euler, right? So now, the second is okay, we already know, okay, the when we write a table, we find that y naught, y1, y naught, y1 is a Euler Taylor's. Okay, we can solve using the Ranch kata order 2, Ranch kata order 3, right? So we learned already in chapter 8. Okay, now we want to continue to our subject, okay, on the um, multi-step method. So in multi-step method, okay, we propose a method, what we call Adam-Bashford method, and the Adam-Bashford-Moulton method. All right. So in multi-step method, we are going to learn in two parts. All right. What is that? The first is a predictor. The second is a corrector. All right. So now we know that the solution of ODE for each point y0, y1, y2, okay, y3, we can get through the Euler method or Taylor's method or Ranskata method. We know already. All right. So after knowing all this point, we feel that the result is not good. Okay, so we want to make better solution. So we want to solve another next point yi plus 1 using the multi-step method, right? Okay, so my answer here, because what? Because there is error between the y0, y1, y2, y3, and the exact solution, okay, from the solving ordinary diffusion equation. Right, so because we see that the error between the exact solution and approximation tends to increase, okay, the error is very bad. Okay, so how to reduce the error? So this is my point here, how to reduce the error. Okay, so at this point, okay, we still going using Euler, Taylor, and Ranskata. So in this case, we propose the multi-step method. We propose the multi-step method. All right. So what is the multi-step method? So this is the equation. All right. The multi-step method that we propose here is using the Adam-Boschford, okay, Adam-Moulton method. All right. So by using the approximation, okay, value that we get from Taylor's, from Euler, from Ranskata, all right. So we know how to predict for the next point, okay, which is yi plus 1, okay, yi plus 1. All right. So now I'm not sure, okay, and anyway, we have a record, okay, by using the approximation here, okay, the next point, okay, for example, yi plus 2, we start, okay, we start using other predictor and corrector method, all right. So for example here, okay, I write the polynomial, okay, polynomial based on the derivative of y prime, y prime prime, y prime prime prime. So we can see here, okay, the what we call as a sequence, okay, for iy plus 1 is, okay, depend on the previous point. For example, to get y3, you need to get y2. You want to get y4, you need depends on y3. So it's already explicit form, right? So now, okay, what is an explicit? Okay, we learn already explicit. Okay, we stop sharing. Okay, I love if I can share with you. Okay, the um okay, wait, I go to the what is the difference between explicit and implicit method. So come on, I hope that you can go to the chat. Okay, go to the chat and then try to answer my question. Right? My question here is what is different between explicit and implicit? What is different? All right. So you go to the chat. Okay, you already learned. Okay, I stop sharing if I can share. Okay, the difference between the, okay, I'm sharing. Okay, the difference between explicit and implicit. All right. So some of you are already answer the question. What is different between explicit and implicit? Go there. All right. Go here. Okay. Go here. All right. So when you can see here, all right, there is a feedback from your friend. Okay, you can answer the question here. Go to the Padlet, all right, click at the top chat. Okay, answer between what is different between explicit and implicit. You learn already. Okay, please give feedback. Okay, give feedback. Go to the link. Okay, get me a feedback. What is different between the um, implicit and explicit. You learn already, okay, through numerical one. Okay, if I can share with you, okay, I go to the numerical 1, if I can share with you. Okay. I on the, come on, we go to the chapter 2. Okay, since you are answering my question at the link I give at the YouTube, okay, I want to stop sharing. I want to go to chapter 2. Okay, we go to the chapter 2. Where is chapter 2? Okay, all right. So in chapter 2, okay, if you can see here, right? All right. You can see here in chapter 2. Okay, please go to chapter 2. All right. Okay, you can go to the link. Okay. Okay, in chapter 2, you learn on Jacobi method. Where is Jacobi method? Go down. Okay, I think you have already the numerical books. Okay, you learn about Jacobi and Gauss-Seidel method. Okay, we go to the Jacobi and Gauss-Seidel method. All right, the iterative method. Okay, down. Okay, this is a you learn about the iterative method. Okay, the first topic you learn is a Jacobi method. You can see here. Okay, all right. Okay, I make it more bigger. You can see here. All right. Yk plus 1 is depend on the, the value of xk is depend on the, at k plus 1 is depend on the all at the k value. So, okay, is we call as a implicit. Okay, explicit. Why explicit? Okay, you go to the chapter 2. Okay, you can go to the chapter 2. All right. Okay, you can see here. Um, xk plus 1, iteration k plus 1 is depend on the k, okay, iteration k, all right. So this we call as explicit. It's really depend to the previous, all right. So if you go to the Gauss-Seidel method, down there, here, down, go to the Gauss-Seidel method, okay, down here, okay. Where is Gauss-Seidel? Gauss-Seidel method is different. Gauss-Seidel method is k plus 1, okay, is depend on the k plus 1. All right. So is using the current value. Okay, the current value for the current iteration. You go to xk plus 1 here, is depend on the 2 point for iteration k plus 1. So we call this one as a implicit, right? So if you go to chapter 9, go to chapter 9, right? I'm stop sharing. I go to chapter 9. If I go to chapter 9, okay, go to the explicit and implicit method solving parabolic equation. I go down, okay. For solving parabolic equation, okay, we go to the parabolic equation. You have 3 methods. What is that? Implicit, explicit, and Kronecker-Nielsen. So when you go here, okay, using finite different method for solving explicit method of parabolic equation of partial differential equation. Okay, understood? Yeah. All right. So I'm using finite different in chapter 6. Okay. All right. Okay, we call this method explicit method. Okay, we want to solve the partial differential equation. You can see here. Okay, to get ij plus 1, to get the uij, I is a grid, j plus 1 is a time step. It depend on the previous time step. So this we call as a explicit. It depend on the previous time step. All right, understood? Yeah. Okay, what is the explicit? Is depend on the previous time step. All right. So now, how we want to avoid this? Okay, how we want to avoid this? we need to enhance this method more powerful, we call as implicit. So now we go to the implicit, drag down, chapter 9, go to the my e-learning. Implicit method here, they said that Cran-Nicholson, you go to the Cran-Nicholson. Actually Cran-Nicholson is a implicit, actually it's semi-implicit. All right, so to get uij plus 1, you can see here, is depend on the current time step j plus 1. All right, to get uij plus 1 is depend on the ui minus 1j plus 1 and ui plus 1j plus 1 is a current value for the current time step. Also, they depend on the previous time step j. Right, so they also depend on the explicit point. So what the powerful of the conjugate what we call Cran-Nicholson is depend on the new time step. It's depend on the current time step. So now, all right, I'm stop sharing. So since you know, what is different between explicit and implicit, I hope, I can share with you. I hope you can answer the question. At least, you know the answer from your friend. You write again because I want you to make a difference. What is the explicit and implicit method? All right. So now I'm change. Go to the. All right. Go to here. All right. I'm sharing my. So there's a few students here. I'm very happy. Some of you answer. The previous and then the current value. So you know what is different between the current and previous value. Very good. All right. So some of you said that this is depend on time. Yes, it's depend on time. For the new grid yi plus 1 is depend on the yi. All right, to know the grid y3 is depend on the y2. So that's we call explicit. All right, implicit, you want to find the value y4, so you need to use y4 at the current, at the current iteration or current time step or the current stage of your calculation. All right, so we call implicit method, to solve ODE, first order ODE using corrector method. Corrector method. We are going to learn. We call as a Adam-Moulton method. All right. So we use explicit. Where we really engage with the explicit before using Euler, Taylor, and Ranchkata in chapter 8. All right. So now you clear. Alhamdulillah. So. Go to the link. Go to the link. Answer my question. What is different between explicit and implicit? You already know. Last week, what is different between ODE and PDE? Please answer my question here. I'm waiting your feedback. All right. So the same time, I'm also want to share. Your. I'm try to stop sharing. I want to go to another feedback from you. I want to see whether you understand what we are now. All right, so this is very important. All right, what is different between ODE and PDE? It's very basic. Alhamdulillah. You are answering many many feedback here. Most of you give a feedback. PDE is what? PDE is what we call as uh, I'm sharing here. PDE is a more on the ordinary differential equation. Is based on the one variable. PDE is based on the multi-variable. For example, okay, del square u over del square dx dy. All right, so alhamdulillah, okay, there's so many feedback here. Okay, very good. All right, so you know, for example, one ODE only one variable, PDE more than one variable. So that's why we have a set of ODE where the temperature of this room is depend on the size and time. Okay, but in ODE we said that the temperature of this room is only one parameter, is depend on the size of this room. So very good. Okay, thank you very much. Okay, thank you very much. Okay, you give good feedback. Okay, I'm now waiting you at this new link. Okay, whether you understand about explicit and implicit. All right, so now, okay, I'm stop sharing. I want to continue, okay, to others, okay, sharing. Okay, I give you through the e-learning. Okay, don't worry. Okay, because I'm preparing already, because it's very important for you. Okay, now as I'm sharing. Okay, go to your e-learning. You can get this equation. All right. So now, all right. So how, okay, this is my question. How to solve initial value theorem y prime equal to x plus xy? How to solve? Okay, the first thing you need to know, what is that? You need to know how to draw the graph. This is very important. You need to know how to draw the graph. Where is the solution? Okay, where is the equation? Right, so you can see here. All right, so I'm drawing the graph here. Okay, I know, okay, based on the question, the x is between 0 and 2. The size of interval is 0.5. Okay, the exact solution is given. So I can, okay, draw the graph like here, right? Between n is equal b minus a divided by h. B is 2, a is a 0, right? So I know I need to find y4, y3, y2, and y1. Y0 is given in the question. So since y0 is given in the question, see, I know that y0 is equal to 1, x0 equal to 0. So this is given in the question, right? Okay, since I want to solve this problem using Taylor's order tree, so I need to find y prime, and y prime prime to obtain, okay, the y1, okay, to obtain y1. So I got, okay, the first value of the graph, okay, y1 by using y prime, and y prime prime, I got y1 is 1.25. Right? So since I know where is the value 1.25, I come back to the graph again. Okay, so you can see that this is a y1. The equation, the value is 1.125. Y0 is equal to 1. All right. So now I continue to get y2, y3, and y4. I continue. Okay, how to get again? I repeat again to find y prime, and y prime prime. I repeat again because what to do? Because Taylor's is depend on the third order differential. Okay, differential here. So what to do? I repeat again. I get the y2. All right, since I get the y2, okay, I know that y2, y3 is depend on y2 because this is a explicit method, single step method. All right, so I know what is y3, and then I continue to get y4 because the graph is n at y4. All right, so what should I do now? Okay, I draw, okay, the answer in the table. Okay, you can see I draw the answer in the table. I know the difference between the exact solution and approximation solution. Okay, I know the between the exact solution and approximation solution. All right, so you can see here. Okay, for more detail, okay, you can go to okay, actually I sent already to your e-learning, so you can go to the video at the e-learning. All right, so never mind, you can go to the e-learning. All right, so if you have a problem, okay, I give you a link at the um, Telegram. All right, so this is a equation. All right, so I send to your chat. Okay, this is a video related to what I'm teaching. Okay, this is a just a summary. So error that I want to express here is a difference between exact solution and approximation solution. All right, so based on this error, you can see here, okay, what the intention we need to do, what is the motivation from this exercise. Okay, from this exercise we want to think how to reduce, okay, the error from Taylor series, okay, using third order, or if you want to use a ranch kata or Euler. Okay, so this is our question here, how to reduce the error. To reduce the error, there are so many ways. We can go for the higher order of the ranch kata, we call ranch kata order 4, or now we can go to the predictor corrector. We go to the method what we call as a predictor corrector. All right. So, okay, the issue now is what is a predictor and corrector. So that is a issue. Right. So my question here is what is predictor and corrector method? Right. Right, method. So this is my question here. Okay, what is a predictor, okay, and corrector method? All right. Okay, so now I ask you to go to your e-learning again. Okay, go to your e-learning. Okay, and then go to the another PDF file. Okay, go to another PDF file. Okay, I'm stop sharing. Okay, I want you to go to the another PDF file. Yeah. Okay. All right. Okay, I'm stop sharing. I go to another file. Okay, I go to another file. PDF file. Um, the equation of the ODE. Go to the e-learning. All right. So we already introduced you, okay, a few methods, for example, aerodynamic equation, Bessel equation, all here. Okay, you can see here, right? All here is what we call as ordinary differential equation higher order. What we call this one is a higher order. Okay, what we call as a higher order ODE. Right? So this we call as a higher order ODE. Okay, Bessel function, aerodynamic. It's not easy to solve Bessel function, yeah. Even though manual, because the answer is infinity. So in this case, you need to use software. I'm going to teach you how I'm using MATLAB, okay, to solve Bessel function, to solve the, because there is a calling function at the MATLAB, okay, for the Bessel equation, right? So this is we call higher order ODE. All right, so since this is a higher order ODE, so the question here is how to solve higher order ODE. We also have another question, is Van der Waals equation. You can see here, wow, okay, there is a mu as a scalar parameter. There is a first order derivative and second order derivative, wow. And then the issue here is how to solve equation 1, 2, 3, 4, and 5. So meaning that how we want to solve all these equation. So this is a problem, right? So in this case, okay, we can solve this problem by using the initial value problem, okay, by using the initial value problem. What is the initial value problem? We have a first start, okay. You have a first start is a y prime equal to fxy, yx not equal to y naught, okay. That's, we start say that this is a initial value problem, yx not equal to y naught, and then we can okay transform okay the question into a graph. You can see here there is a graph. Okay, let's we go to the graph. Okay, the graph you draw is what is a domain of the solution between x naught and xn. All right, what you intend to do, you want to find y1, y2, y3 up to yn. All right, so this is we call as a first step method. Just involve one method we call as Euler or the Taylor or Ranch-Kata. All right, so to solve this problem, okay, you have the one single step method. Okay, you already know how to solve the ODE first order using Euler. Okay, where the formula is yi plus 1 equal to yi plus h f. So remember what is f? F is a y prime. And then Taylor methods with the higher order, okay, with the third order derivative, okay, fourth order derivative, second order derivative. And then we can also use Ranch-Kata. Okay, the best one is a fourth order derivative. All right. So now we already learned this method, okay, in the chapter 8. Many times I say chapter 8 because chapter 8 will help you to solve single step using Euler, Taylor, and Ranch-Kata. So what you are going to intend to do now to improve the error, okay? To improve the error, okay, what should you do? We have the what we call this one is a what we call predictor corrector method. What we call predictor corrector method, right? So now, this is the way we can solve the problem. Okay, okay. Let's we continue to the okay the predictor and corrector method. Okay, so since a very heavy raining now, okay, I think it's not secure, okay, to continue. Okay, I post you the video at the e-learning, right? So the lightning is quite okay dangerous for me to continue. All right, okay, you can see the sound very heavy rain. Okay, we stop now. All right, so let's we go to the exercise. Okay, okay, the exercise here. Okay, I hope you can go to this link, right? And stop sharing. Okay, and stop sharing. I go to a simple exercise, okay, using GeoGebra. I know some of you have the experience using GeoGebra, right? Go to the GeoGebra, and then you can see my okay my view here. All right. Okay, this is a exercise. I send you a link. Okay, you go to the link, right? Okay, I send you a link. Try to solve what you learn in chapter 8 using GeoGebra. Why GeoGebra is very good to visual the graph. Okay, to visual the graph. So I give you example, right? Go to the GeoGebra, right? And then try to draw the graph. Okay, try to draw the graph for any okay first order derivative in chapter 8, and then you can see okay how the GeoGebra can draw your graph, can get the solution for y1, y2, y3, okay, y4, right? You can choose Euler, you can write okay Taylor's equation with the higher order to get a very accurate okay, solution. Right, see you at the GeoGebra, right? Okay, I want to see you at the GeoGebra. Bye bye. We'll see you at the